Okay, looking at section 11.4, we're going to continue with factoring, but they created a special section for something called special factoring techniques. And you might just see that these look a little bit different than the trinomials that we were working on. Looking at letter A, we start with a binomial here. And some things that might help you when you're working on this special factoring technique is to remember there are these numbers that are called special or square numbers, like 2 times 2 is 4, so 4 is a square number. And you might remember your squares are 1, 4, 9, 16, 25, 36, 49, and I'm just multiplying, 7 times 7, 8 times 8, 9 times 9. So kind of remembering your special numbers, the square numbers. So you spot this 16 here and you're thinking like, okay, that's 4 times 4. And then you see that x squared, and that's x times x. So I'm going to try my technique of 2 binomials here. And I'm going to put a 4 and a 4 to get the 16. And then I'm going to use an x and an x to get the negative x. But I'm not quite finished here. I have to put a positive sign and a negative sign so I can get the negative x squared. And so what you see here is kind of something, you get binomials. They aren't opposites of each other. It's just that the sign in the middle is different. Okay, and what this is called when you see something like this is called conjugate pairs. All right, and so this thing right here, since the sign in the middle is called the difference of squares. And so it has a little ring to it. The difference of squares factors into conjugate pairs. Okay, so this is the conjugate pairs here. All right, so let's look at another one of these. And it might be conjugate pairs or it might be something different, but I see that y squared, that's y times y, and I know 9 is a perfect square. It's 3 times 3. And this can break apart into x squared times x squared. So I'm going to write down my 2 binomials. I'm going to put y times y to get that y squared. I know it has to be a plus and a minus. It could be minus plus, it doesn't matter. You just have to have an alternating sign. And then I'm going to use the 3 to get the 9. And then I have x, but it's not just x, it's x squared, okay? You have to have that x squared in there. And so what we see here again are conjugate pairs. Okay? So this is why it's falling into this special factoring category. Okay? Now this one, C, doesn't look like conjugate pairs. We don't have the 2 terms, but we do notice that, hey, 9's a special number. It's 3 times 3, and 25 is a special number. It's 5 times 5. So I'm going to try to factor this. I'm going to use 3 and 3. That'll produce the 9. I'm going to use 5x and 5x because that'll produce the 25. Now I'm not 100% sure this will work until I do a quick check of that would be 15x. That would be 15x. I'll just write that down for you. 15x. 15x, and you see that makes the middle term 30x, okay? So it does work. This is a correct answer, okay, that writing it with the 2 binomials, but some might prefer to write it this way. It's just a little fancier notation, It just shows you, hey, that's the power, the rule of powers. If you have 5 times 5, you can write it as 5 squared. If you have the binomial 3 plus 5x times the binomial 3 plus 5x, you can write it as the binomial squared. Okay. Let's do a few more of these. Let's look at D. So we see 4. 4 is a special number. It's 2 times 2. So I'm going to try something here. I'm going to use x and 2 and 2. But I somehow get a negative introduced to this problem because there is a negative here. Well, if I put a negative, that'll get me positive 4. And also if I check outside and inside, okay, it will get me to negative 4x. So this is an okay answer. But if you want to write it a little fancier way, you can write it as a squared binomial. Okay. All right, looking at the next one. You're hopefully getting the hang of this here. We see the minus sign in the middle, and these are perfect squares. So I'm going to write down 2 binomials here. I'm going to write a 5 and a 5 to get to 25. I'm going to write a y and a y to get the y squared. And then to get the minus, I'm going to use a plus and a minus. Then I'm going to write a 4 to get the 16. And then don't forget about your x's. You got to write an x squared and an x squared. Okay? It's like splitting it apart into 2 pieces, 2 binomials. All right. Looking at f here, I see a special number, the 16, so I'm going to try 4x and 4x, and then I'm going to try y and y to get my y squared. And then I got to introduce some negatives into the problem, or a negative, so I'm going to put a double negative here so I can continue to get this positive y squared here. And you can see why this would fall into special factoring, because it can be a squared binomial if you want to write it out the fancy way. Okay. Now let's finish up these last 3 in this video here. Video is going to get a little long, but we can wrap up 10.4 here, at least the first part of it, or 11.4, excuse me. So here we have a GCF, and if we didn't factor out that GCF first, we might not have noticed anything special. But then this can factor into 3x plus 2, 3x minus 2, and we bring our GCF down. This again is the difference of squares, and we get conjugate pairs. Don't forget your GCF. Okay. This next one here gets a lot of students confused because they'll try the method of putting the 3x and the 3x, and then they'll say, well, I need to get a 1 here, so I'll put a 1 and a 1. Now there's no negative signs in this problem, so I'm just going to put positive and positive, and they'll come up with this as an answer. Now if you check that, the problem is outside is 3x and inside is 3x, which makes 6x. And there's no 6x in this problem. Okay? So then what students often try is they'll try 3x plus 1 squared. And they'll say, well, I'll square this and square this. The problem with that is that's not squaring things correctly. If something is squared, it means to take it, there's it, times itself, and we're right back where we started with. So we get stuck in this loop of nothing will work. Okay? Now this is called the sum of squares. And the sum of squares, okay, is not factorable. All right. Now some people say not factorable with real numbers, but right now with intermediate algebra we'll say it's not factorable. Okay. Now let's do this last one here. We see some special numbers, 16 and 9. So I'm going to break this apart into 4y and 4y, and then I'm going to say 3x and 3x. No negative signs in this problem, so plus, plus, and then I'll just double check here. That's 12xy, That's 12xy, which would make 24xy. So remember, the fancy way to write this would be to write it as a binomial squared. But both of them should be acceptable answers, okay? All right, that wraps up the first part of 11.4, Special Factoring Techniques. Thanks.